Welcome to the presentation of Chapter 15 from the DevOps Handbook. Today, we will be talking about the outlier detection, means and standard deviation, alerting, non-Gaussian distribution, a case study of Netflix, anomaly detection techniques, and a case study of advanced anomaly detection. Outlier detection, originally defined by Victoria J. Hodge and Jim Austin, means detecting abnormal running conditions from which significant performance degradation may well result. Roy Rappaport of Netflix explained that they used the principle to identify and isolate nodes which were not performing in a normal condition. They just had to determine what was normal behavior and monitor for variation. By finding a node that was not following the normal pattern, they killed it and then notified the engineers after. The implementation of server outlier detection has allowed them to reduce their efforts to find bad nodes and time required to fix them. Mean and standard deviations is a technique used to analyze production metrics, which involves creating a filter to detect significant variations from the norm and generating an alert. Alerts are intended to draw immediate action to resolve the issue. However, excessive alerts can cause alert fatigue, especially when they're continuously waking people up in the middle of the night. Fine-tuning these alerts can be done by increasing the signal-to-noise ratio. The Gaussian distribution, as shown on the right, helps accomplish this. The vertical line in the middle represents the mean. The other vertical lines represent the standard deviations. Setting alerts for 3 standard deviations prevents alert fatigue, but still catches problems. Tom Limoncelli once jokingly said that we should eliminate all existing alerts and replace them with alerts for known indicators that could prevent system outages rather than be bombarded with alerts after an outage had already taken place. The idea is to figure out what the indicators are and monitor for them. This can be achieved by analyzing past incidences and creating telemetry that would allow for quicker detection of potential problems and, in turn, quicker resolutions. In the provided list, there are 4 leading indicators that can catch issues early on, and hopefully before they become severe problems. Not all datasets work with the Gaussian bell. The example on the right shows a dataset that does not follow the bell shape and would regularly be 3 standard deviations from the mean, which would be everything above the black line. Instead of the bell shape, these datasets have chi-square distribution, which does not work with standard deviations. Netflix, however, came up with the solution for non-Gaussian distribution.
So let's take a look at exactly what Netflix did with their autoscaling in 2012. At this time, Netflix was using Amazon Autoscaling, or AAS, which changed server counts based on workload data. This caused rapid spikes in demand that couldn't be met in time, which led to dramatic decreases in demand after outages as customers couldn't stream, meaning it then removed too much compute capacity as a result. On top of this, AAS didn't factor in known patterns. To address these issues, Netflix developed a tool called Scryer. Scryer works by predicting what customer demand will be based on documented patterns and allocates the appropriate capacity. Netflix is able to take advantage of the fact that their customers' usage patterns were consistent despite not having Gaussian distributions. Take a look at this chart. On the left is the predicted workload Monday through Friday per second. Scryer uses a combination of outlier detection, such as fast Fourier transform and linear regression, to smooth everything out while preserving data spikes, which is what we see in effect on the left. This led to Netflix significantly improving their service availability, customer experience, and reduced Amazon Cloud Services costs. When lacking a Gaussian distribution, variances can still be detected with a variety of methods. These methods are known broadly as anomaly detection, which is, quote, the search for items or events which do not conform to an expected pattern, end quote. The most important facet of this is that it involves monitoring tools and statistical skills. This calls for a collaboration between operations and statistics. Now let's take a look at a key statistical technique, smoothing. Smoothing involves moving or rolling averages by averaging each point. This has a smoothing effect on the short-term fluctuations. Take a look at this chart. The blue represents the actual data, while the black line is the 30-day moving average, which was generated via smoothing. You can see how the small peaks and dips of the data are smoothed out into a continuous line. This is why the method of averaging is known as smoothing. Now let's take a look at an operational technique, fast Fourier transformations, or FTT. FTT is a more exotic technique widely used in image processing. It is used to find similarities and/or difference in periodic metric data. Let's take a case study for advanced anomaly detection, which was done at Monitorama in 2014. This particular case study highlights how different methods can be appropriate or inappropriate depending on the organization and/or data. This particular chart shows the number of transactions per minute at an e-commerce site. Note the weekly pattern developing. Just at a glance that we can see something is wrong within the 4th week. However, using the 3 standard variation method, we'd only be alerted twice missing this event. Ideally, we'd want to be notified that there has been a variation in the Monday pattern. Here we see the Kolmogorov-Smirnov test, also known as a KS filter, which makes no assumptions on normality. For our case study, this means it catches all 3 alerts, including the Monday drop-off that was missed with the 3 standard deviation method. This is critical in complex systems, allowing us to understand what is going on at various levels. In conclusion, outlier detection is detecting, quote, abnormal running conditions from which significant performance degradation, end quote. Means and standard deviation is a technique used to analyze production metrics, which involves creating a filter to detect significant variations from the norm and generating alert, which is intended to draw immediate action to resolve the issue. Alerts are on the application, OS, database, and network levels. Not all data sets work with a Gaussian bell, resulting in non-Gaussian distribution. We took a look at a case study at Netflix, specifically their auto-scaling tool, Scryer. Anomaly detection is the search for items or events which do not conform to an expected pattern, which involves monitoring tools and statistical skills. And we looked at a comparison of the simple 3 standard deviation method versus more advanced anomaly detection, Kolmogorov-Smirnov test, which is also known as a KS filter.